Good afternoon, class. So at this point, you guys have got your results back. Okay. Please go through the memo. I've sent it to the group and do your corrective work. If you have any problems, please let me know. You can come on break and we can sort your issues out. Okay. So at this point, we were busy with functions. Okay. We don't have time now to go through all those questions because, as you know, we are running out of time. Okay. For homework, I gave you exercise 7.1. Not so. So in exercise 7.1, whoever's phone is that, please put it on silent. It says list the domain and the range of each function. So if you're looking at number 1, list. So normally list we put the squiggly brackets. So your domain is an element of, and we list -2, -1, 0, 1 and 2. The range is an element of, belongs to the set -1, 1, 3, 5 and 7. Not so. For B, again, your domain is -3, -2, -1, 0 and 1. Your range is -6, -4, -2, 0 and 2. Again, what is domain? Domain is a set of all x values. The range is all the y values. We're looking at the mapping here. The mapping that was done here. C is going to be -1, -2, 0, 1, 2, -1, 1, 3, 5 and 7. Okay? D, your domain is -3, -1 and 1, 2, 3. You don't write 3 twice. You all okay with that? Kumalo, looks like you didn't do your homework. You did it. Now why are you not marking it? Your book is not here. Why are you disrupting other people in the class? Come on, man. You're looking at E now. A mess. Your domain is normally your input values, not so. So here it's going to be 30, 40, 50, 60 and 70, and your output values is 125, 130, 135, 160, 185. It says here, which illustration describe the same function? Same function. -2, 2, 7. No, that one's not for that. -2 to 1, -1 to 1. Can you see that 0 and 3? So A and C is together. Can you see that, people? Yes. 2 and 7, 2 and 7, 1 and 5 and so on. So let's see which connects with us. -3, -1, -3, -1. No. -3, no. Okay, so it's just those two, it looks like it, no? Right. Let's go to C. Write the function as a set of ordered pairs for this year. So what would this be? Your input is 1, your output is 10. Your input is 2, your output is 10. Your input is 3, your output is 10. You got 4 and 20, as you can see here. 5 and 30, and 6 and 30. Okay? You want to look at with that? Then we went into functional notation. We said that the symbol f of x describes the element of the range of the functions for each element of the domain, and we spoke about that there. We said that there was a repeated question here. The question is explanation and the example is the same. We did that there, we did this, we did that. We didn't have to bring that Mickey Mouse with. Right, 7.2. I asked you to do 7.2, correct? So in exercise 7.2, this was on page 142. Okay. So it says calculate the value for f of x. Calculate the values of for f of x equal to 3x. So the first one is f of 2. So I say f of 2 equals 3 times 2, which is 6. B, f of minus 2. So if I see x up to minus 2, 3 times negative 2, which is negative 6. So C, what do you notice here? They want you to calculate if f of x is equal to negative 9. But what is f of x equal to? 3x. The 3x equal to negative 9 divided by 3? Negative 3. D, they want you to solve A. If f of A is equal to 1. So in x's place I'm going to put A. So 3 times A. F of A is 3 times A. Can you see that, people? And that's equal to 1. So I divide by 3 both sides. So x is equal to, sorry, not x but A is equal to a third. You all okay with that? Number 2. Oops. In question 2, determine the range of the function if the domain is that big. So the domain is given, and what is domain? All possible x values. Not so. So x is 1, 2, and 3. So in other words, I'm going to work out s of 1. So it's going to be 2 times 1 minus 5. Remember, that's the equation. Gives you an answer of negative 3. So s of 2 is 2 times 2, which is 4 minus 5 is negative 1. S of 3 is going to be 2 times 3 minus 5, which is 1. So what is my range? The range is an element of negative 3, negative 1, and 1. You guys understand? They asked you to write it in ordered pairs. This was not asked. It will be 1 and negative 3, 2 and negative 1, and 3 and 1. You see that? They'll ask you to write it as a, what was the other one? It was not a flow diagram, what was this? Mapping, yes. So 1 will map to negative 3, 2 to negative 1, and 3 to 1. This mapping, okay? Are you okay with that? Next question. Question 3. Question 3, we are told the formula f of n is equal to n minus 2 times 180 can be used to calculate the sum of the interior angles of a polygon. What's a polygon? It's a closed figure made up of n amount of sides. It must be made up of edges, straight lines. Right. So A, use a formula to calculate the number of interior angles. Calculate the sum of the interior angles of a 5-sided polygon. So N represents your sides, not so. So if you got a 5-sided polygon, so it's f of 5 equals 5 minus 2 times 180. What's 5 times 5 minus 2? 3, and 3 times 180? 540. A 5-sided figure is also called what? Pentagon. Not so? If it's, what does a regular pentagon mean? All sides, all angles are equal. Irregular, all the sides and all the angles are not equal. Okay. B. Use your formula to calculate the number of sides a polygon having if the sum of the interior angles is 108. So f of n is 108. Can you see that 108 over? So it's 1080 equals n minus 2 times 180. So what I do is I divide 180 both sides. Not so? So n minus 2 works out to be what? 180 divided by 1080 divided by, should be 9 or something. Yeah, 9. Just check there. 1080 divided by 180. 6. Yo, something wrong with my maths. So n is equal to 6 plus 2 is 10. So the 8-sided figure's interior angles will be equal to 1080. 8-sided figure is also called what? Octagon. What is an irregular octagon? 8-sided figure, all angles and all sides not the same. Okay? You all okay with that? Alright. Let's look at number 4. Number 4 is given the function f of x equal to 2x minus 1. Evaluate, calculate, determine, all means the same. Okay, simplify. So 4a, to us it means the same. 4a, f of x equal to 2x minus 1. So what is 2 f of x? If f of x is 2x minus 1, what is 2 twice f of x? So it will be, f of x is 2x minus 1, so that will be 2 times 2x minus 1, which is 4x minus 2. Let's go to b. F of x minus 2. What is f of x? 2x minus 1 minus 2, which is 2x minus 3. C. F of 2 of x. So what happens here? Wherever we see a x, we put a 2x. Can you see that, people? So that will be 2 times 2x minus 1, which is 4x minus 1. You all agree with that? You all agree? Yes, sir. Yes. D. You must say. How would you? D. F of x minus 2. So wherever we see an x, we put a x minus 2. Can you see that, people? So that would be 2 into x minus 2 minus 1, which is 2x minus 4 minus 1. 2x minus 4. Will you guys understand? Right, you must start working at your maths, no? Now you say, You must remember, the day you get your maths, your final result, they don't say Mr. Bardin couldn't teach maths, or he don't know what he was talking about. It is just your name, your ID number, and your maths form. You know that? You guys know that? When you get your matric result, your final result, he doesn't say all the hardship you went through, and you came to school, there was no papa, you couldn't think. So Bardin couldn't teach maths, he was never in school, he was always eating his lunch during LP. Nothing of those stand on that maths and their own list. You understand? So you must work towards what you want on that certificate. You can't just say you want the 50% and you put in no time. Or you skim through your work like I was told earlier on. No? I just skim through the video, or I skim through. Nee. Imagine you get a skim mark. Do you like that? No. So put in the time, people. Alright, let's go. F of x is equal to? And this is such a beautiful subject. It is. Right. People, here we got f of x equal to x plus 1 over 2. Show that. So it's a show that question, or a prove that question. For prove that or show that question, I don't use this in the sum. I can't use it like it is there. This is what we call an identity. The one side equal the other side. So let's go. The left hand side. left hand side equals f of 2x minus 1. So that means to say, wherever I see an x, I put a 2x minus 1. Can you see that, people? So we say, that's going to be 2x minus 1. That is now your x here, not so? 2x minus 1 plus 1 over 2. That's gone. So I got 2x over 2, which is equal to x. You see your left hand side is equal to x. I say, hang on. It's equal to the right hand side as well. So I say equals the right hand side. And they have proven now, or showed that the left hand side is equal to the right hand side. You guys understand? Number 6. Show that. Here's another show that. Okay? Tita, why put this up on your lips? For who is that now? For yourself. Okay. Number 6. Welcome. Glad you made it. Show that. So, f of 2 plus x equal to. So again, left hand side, right hand side story. Left hand side is equal to f of 2 plus x. So in x's place, what do? I put a x plus 2, 2 plus x. So there goes. Open brackets. 2 plus x minus 2 squared minus 1. Not so? So let's cancel. Give me x squared minus 1. So is that equal to the right hand side? No. So what do? I work the right hand side as well. So what do you have on the right hand side? You have f of 2 minus x. So what do? In x's place I put 2 minus x. Not so? So there you go. Open brackets. 2 minus x minus 2 squared minus 1. Again, 2 cancel 2. What's negative 1 squared? Sorry, negative x squared. X squared minus 1. But say, hang on. Left hand side is x squared minus 1. Right hand side. So this is equal to the left hand side. Can you see that, people? I can't believe it's so easy. I can't. Okay. Look at number 7. In number 7, the range of people. What is range? Y values, not so. So the g of x is normally where y goes, not so. Is that right or wrong? Right. So the range is 0, 3 and 8, which means to say the y values are 0, 3 and 8. You guys understand? So we do the substitution. So 0 equals x squared minus 1. How do we solve for x here? One of two ways. You can either do difference of two squares, not so? X plus 1 minus 1. So x minus 1 is equal to 0, or x plus 1 is equal to 0. We get over the equal sign. So x equal to 1 or negative 1. Okay. Let's look at the next number now, 3. So 3 equals x squared minus 1. Take it over the equal sign. So 0 is equal to x squared minus 4. Difference of two squares. So what do we get? X plus 2, x minus 2. So x plus 2 is equal to 0, or x minus 2 is equal to 0. So x is equal to minus 2, or x is equal to 2. Okay. And I'm sure you know what to do for 8. The answer is plus minus 3. Number 8. Show that. You see how nice the show that questions is? So, g of x equal to 2 to the x. So the left hand side equals twice g of x. So hang on. G of x is what? G of x is equivalent or equal to 2x. So it's 2 times 2 to the x. When we multiply and bases are the same, what do you do to the exponents? Add them. So that's 1 plus x or x plus 1. Not so. Let's look at that. Is that the same as this side? No, not yet. So let's go to the right hand side. So the only time we work both sides is if you can't let the right hand side equal to the left hand side. That's what you do. Not so. So you look here. Okay. G of x plus 1. So wherever we see an x, we put a x plus 1. So it's going to be 2 to the x plus 1. Now is that not the same? Yes, so that's equal to the left hand side. Okay. And that brings us to the end of it. Okay. Functions and graphs. So I'm just going to refresh your memory here, because these things you guys should be familiar with already. Graphs and functions, we're reading from page 143. Page 143. Okay, examples on page 143. We are told the function notation is often used when graphing functions, or drawing functions. Okay, write that note down. You guys remember how to draw straight line graphs? Huh? You didn't do straight line graphs last year, Michael. You did? They don't have to do straight line. So I didn't want to give you this exercise for homework because it's a lengthy exercise. But now you don't understand, so now I must give it to you guys. What's wrong with you? Right. So the example on page 143, we are told for the function g of x equals negative x over 2 plus 1. Calculate the value of g of minus 1, g of 0 and g of 2. So what do I do there? You substitute negative 2 where you see x. Not so. So in the first case, g of negative 2 is equal to negative 2 over 2 plus 1. Not so? That's going to give you an answer of 2. So this ordered P is negative 2 and 2. Now you do the same for G of 0 and G of 2. Okay, so G of 0 works out to be what? 1. Not so? G of 2? 0. So the ordered P is 1 and 0. And 2 and... No. This is not 0 and this is not... This is 0 and 1. What's wrong with you? And 2 and... 0. You all agree with that? Right. So let's look at the next question. The next question says, draw a straight line defined by the equation g of x equal to negative x over 2 plus 1. So that's the graph that we just worked out, that we just worked the coordinates out of. Not so? So work that out for me. Draw the graph on the axis of the Cartesian plane. I'm just going to put this here so you can move that down. Let's pause here again. Freeze, not pause. Right, so let's draw. So what is the first coordinate? Negative 2 and 2. Not so. And then 0 and 1. Then 2 and 0. Not so. So we take our line, draw a line through there. Not so. This time of the day, this thing doesn't want to play along. And there we go. There's a graph you guys will draw, not so? Sorry? Right, there we go. That's the graph. This is the graph of G of X. Use your graph to determine G of minus 4. So what is this, a X over Y value? It is a X. What we do is you go on the graph at minus 4. So G of minus 4 is equal to what? 3. Can you see that? If I had substituted minus 4 into G of X, minus 4 over negative 2 is 2 plus 1 is 3. Can you see that, people? So I could read it off from the graph. What is G of 4? What is G of 4? It's going to be negative 2. Can you see that? What's the value of X if G of X is equal to a half? This was now a Y value, not so. Where's G of X is a half there? And what's your corresponding X value? 1. You see, you can work in reverse as well using your graph. Alright. Use your graph to determine, I just did it, G of minus 1. G of minus 1 is 4. Determine the domain and the range of G of minus X over 2 plus 1. So if you look at the domain, what is domain, people? Domain is all possible X values. You see, this graph goes all the way to negative infinity and positive infinity. So for that we say that your domain will be X is an element of all the real numbers. So all the values for X will exist on this graph. You guys understand? What is the range? The range is all possible Y values. So the graph goes down to negative infinity and positive infinity. Can you see that? These are normally arrows at the ends of these straight line graphs, not so. Which means to say it's going to negative infinity and positive infinity. There we then say Y is an element of all the real numbers. So all the real numbers exist for the range as well as for the domain. Okay, you guys understand? Right now. I would like you guys to do exercise 7.3. Okay, we will just skim through it tomorrow. We can see what the issues are. Okay, so you guys can start with it now quickly. We'll stop the video at this point. Okay.